Cool. Okay, so welcome everyone. It is now 5 o'clock, and so we're going to get started. And we've said our hellos. And just to remind you in future, if you get here 5 minutes early, the room will be open. We'll be chatting and just informally chatting and getting ready for the lesson. And so now what's going to happen is we are going to switch the setting in the Zoom to mute, just so that we can make some announcements, we can get going, but we really do want to hear from you in the chat. Okay, and then so just reminders before we get started, in case you're new, I know many new students are joining us. Make sure that you are sitting at a desk somewhere or a space, you're sitting with a book and you're ready to write, that you are using the chat. So that's this picture over here, what it means. We will mute you some of the time, although you can unmute yourself in other times. And so, yeah, we're just going to do this warm up. I haven't seen any answers come through so far. And so I just want to give you a hint. Who knows what the what is the red square? Does anybody know what the value of the red square is going to be? I would love to know what number times itself again gives you 27. Can anyone help me out there? I see a 9 and I see a 3. Okay, any other ideas? So I think that it's 3, because 3 times 3 times 3 is 27. So if we know this is a 3, can we now figure out what the green triangle is? I would love somebody to put in the chat what the green triangle needs to be. And just give it a go. Maybe you get it right, maybe you get it wrong. We're just warming up our brains now. We're stretching in the gym. We're going to give our brains a chance to get moving. Our brains are a muscle. So actually, maybe our brains aren't a muscle. I don't know. I'm not very good at biology, to be honest. Or life sciences, I believe, as they're called these days. So I see some answers from Liz. I see some answers from Micah, from Ryan. Okay, now there's 4, okay, there's lots of answers. This is interesting. Well, I know that there's a couple of different ways of doing this, but I was thinking 8 times 3 is 24, right? I know that from my times table. But the problem is I need these 3 triangles to multiply to 8. And the only number I can think of is 2. So now we know the green is 2 and the red is 3. Can you figure out for me what the circles are going to be? Now, all of these numbers are whole numbers, hey? So what is the blue circle going to be? That's your next question. What are these guys going to be? Or these girls, I might say, are going to be. Any ideas? Let's keep it coming through the chat. And absolutely, I know, a very warm welcome to our new students. If you are feeling a bit, this is up and running quickly. This is our warm-up activity, and then we will do some announcements in a moment. Okay, I see some answers, 6, 4, etc. So I guess my brain was thinking 6 times something gives me 96. Well, I suppose I shouldn't even use a square. 6 times, something gives you 96. But now, what is that something? I guess it's going to be, is it going to be 16? 6, yeah, it's 16. And then the question is, what 2 things multiply together to give me 16? It's going to be 4 times 4. And so these numbers are going to be 4 and 4. Now, if you're feeling a bit confused by this, don't stress. It's just a fun problem solving type thing. So the final question. Well, let's just make sure everyone gets that. So basically, 3 times 2 is the 6. So that's the 6 over here. And now what I realized is that 6 times 16 will give me the 96. But then I have to say, what number can I break 16 into? Or what factors do I need to break 16 into? And factors is a word we've mentioned quite a lot. And it's going to be 4 and 4. And so now the final answer, what is the final answer? The final answer is going to come from going 4 plus, what is this? This was 3, and this was 2. Now, using BODMAS, I need to multiply the 3 and 2 together first. So 4 plus 6, I get 10. Palesa, you are on the money. Well done. Now, I know this was a little bit harder than normal, but just give me a sense of how you enjoyed it. If you enjoyed seeing something different like this, thumbs up. If this was a little bit too much, give us a thumbs down. I would love to see your response, because as a teacher, I like to try new things, and sometimes they work and sometimes they don't. And so it's important that I get feedback, and you can be completely honest. I will not take it personally at all. So most of you seem to enjoy the challenge. It's like a tough workout. You know, sometimes it's tough when you're doing it, but you enjoy it. Okay, so let us, what have I done? Somehow I've managed to preserve my screen. Let me just, interesting. Okay, technical, I've made my OneNote upset. Let's,
So while you sort out your screen, I'll ask the learners if they want to do more of these types of questions in the future, and they're definitely eager to do more of them. So I think
fantastic.
maybe make a point of it at least once a week, do a puzzle like this or something.
Yes. So what I'm going to do is I'm just going to close my OneNote for a second. Apologies, guys. We've had some technical glitches. You can see me in the full screen size. And hopefully when I open it up again, oh, look at that. Like magic. Is gone, but I'm not sharing my screen, I guess. So let's share the screen. And wouldn't you know, it's the tech gremlins have been chased away, or at least, let's see. Well, guys, at least you know I'm live on the internet because, all right, so Anya, are we going to go to the announcements part of the lesson? Is there anything that the students need to know about, or anything, comments or things that you have? I can't remember.
No, I think there's something really too important. I'm just going to reiterate what we said last week, and I see Kamu Ehlu already asked a question about the test. So, or yes. Quiz rather, pardon my language there. So guys, just a reminder, if your free trial period is over, please speak to your parents they should have received the WhatsApp about, sorry about that. About payments or so please go ahead. If you only started your free trial recently, then that is obviously not applicable. And then at the end of this lesson, I'll post the link to the quiz in the chat. I can only send it towards the end of the lesson. If you are new to Watobe, you need to sign in on the Watobe site.
Yes.
So that's, I think, Sir, and I will just remind you guys about
that. I'll go through that now. You're right. So basically, thank you so much, Anya, for those reminders. So basically, with Watobe, when you start, you get a 2-week free trial. But then after that, if you've enjoyed it and you found it beneficial, we really want you to let your parents know, because we will send a message to them saying, if they would like to continue, there's a fee. I think it's 299 Rand a month or 75 Rand a week. And you need to tell them that you are finding it beneficial, for them to not get confused when they suddenly get a message. So that's an important announcement. And then at the end of a second lesson every week, so this is Wednesday, the second lesson, we do like a fun formative assessment or quiz at the end. And so in order to do that, you need to be signed into the Watobe website. And so if you don't have a login on the Watobe website, you'll have to get that in order to participate in the fun quiz. Okay, and I think that's all the admin. If there are problems later in the lesson, we can always tackle them there. But I think we're all hungry for some maths now, so let's get going. So for those who have been with us for the first time today, I just want to quickly highlight what we've been up to lately, and then I want to carry on with what we were doing. So these are the topics that we have been talking about and doing in different ways. So classifying numbers, number operations, BODMAS and PEMDAS, on all these things here. And recently, we've been focusing on what's called the highest common factor the lowest common multiple, which is more going to be today, and prime factorization. So these are the things that we're going to focus on today again. And these are some of the things we've covered in this unit on whole numbers. So that just gives you a feel for what we've been up to. And in the last lesson, when I left you, we were speaking about finding the highest common factor or the lowest common multiple of these numbers over here. And I just want to finish that question off. So let me start by doing that. If we look at the numbers 24, 28, and 42, if we want to use the prime factorization technique on that, we should get 3. 28 is going to be 2 times 2 times 7, and 42 is going to be 2 times 3 times 7. Give me a thumbs up if you understand that. Give me a thumbs down if that confuses you a lot. I just want to get a feel for if you remember that from the last lesson, and if I can carry on from there. So let's just thumbs up if that makes sense to you, a thumbs down if it doesn't make sense to you. Okay, so let's go forward from this. So now if I want to find the highest common factor of these things, we said that we look for what's in common. Basically, what has a friend in every one is in common here and here. Is it in common anywhere else? No. And so the highest common factor for this first round is going to be 2. Now let's move to the second one. Let's move this out the way. Get rid of this. And that. And I asked you for homework to complete the ladder method for these things. And so we are going to go on to the next 2. And I was writing in the answers before. And I want to know now, I've got the prime or the ladder method factorizations. In the chat, I want you to post what you think is the highest common factor for B and the highest common factor for C. And remember, I've done the factorizations for you over here. So I'm going to give you about maybe a minute or so to think about this. What do you think the highest common factor is for B? And you can use the working out that I've done for you. What do you think the highest common factor for C is over here? And I'm just going to wait a little bit and give you a chance to try and complete that. And if you can't do B, just try out C. This is interesting. 17 looks like it might be a difficult case. What's special about 17? Okay, I think B is a tricky one. Well, not tricky one, but it's a bit of a weird one. With C, what do we have in common? Well, we have a 3, no, only in 2 of them, so we take that out. Do we have a 5 in common? We have a 5 here, a 5 here, and a 5 here. Is there anything else in common to all 3 of these? So guys, I think you are smashing it at the moment. The answer for C is going to be 5 because it's the highest common factor of these 3 numbers, and you can see it so beautifully in the ladder method. What about B? What was the answer for B? Turns out the highest common factor for B is going to be 1. And the reason it's going to be 1 is that, well, 17 makes it very difficult because 17 is a prime number. And so the other numbers would have to be a multiple of 17 to be helpful. But I think, Anya, on the whole, it seems like that was pretty well done. Can I move on from that?
Yeah, just one hand. Unfortunately, do not know the learner's name.
Okay.
But in the user tag, there's a lot of A's. I've tried to ask students to rename. It's
Okay.
1JWC has got their hand up.
Okay. We'll get to them shortly. I just want to try and make sure that students are up and running on this. Let's just try this last one. So the last one is D. And for D, we've given the numbers 18, 30, and 45. And I want you to find for me the highest common factor of these three.
But overall, the kids are doing like really well, just to actually answer your question. So
that's fantastic. Thank you. Because there's so many
hard work.
Chat, it's 3, 3, and 3. So 3 is the only one that has a friend in every single number. And so that's why, because I thought maybe 2, but you can see 2 has a friend next door, but it doesn't have a friend right across. So the highest common factor of this is going to be 3. And so I hope that every time we do this, it gets a little bit easier to find the highest common factor, but I'll give you more chance later in the lesson, but I want to move the focus now to something slightly different. And so we're going to move on a little bit. Okay. Now, in this question, the question actually says, find the highest common factor and the lowest common multiple of these numbers. But I'm going to focus just on the lowest common multiple to make things a bit easier for us, because I haven't really talked about the lowest common multiple that much. So whenever we find the highest common factor or the lowest common multiple, there's always a short way and a long way. The long way to find the lowest common multiple of 5 and 7 would be to literally write out all the multiples and see what happens. So the multiples of 5 would be and those are the first 7 multiples of 5. The multiples of 7 would be that. Now, you can imagine as the numbers get bigger, it gets much harder to find the lowest common multiple. I found one. It is, in fact, 35. But you can imagine how long it would take me if I didn't have a better method to do it. So what I'm going to do is I'm going to show you how we can use the ladder method to help us to find the lowest common multiple. But it's a slightly different way of doing it. It's not the same as the highest common factor. And so we need to make sure from the very beginning that we separate those two ideas. Otherwise, it can get a little bit confusing. So I know that I'm going to do it as if it was normal. Okay. So 5 and 7 are actually both prime numbers. And so the prime factorization is actually just going to be this. And then what we're going to do is we're going to say, well, what are the 2 factors involved in these 2 things? The only 2 factors that are involved are 5 and 7. And what are the powers of the 5 and 7? Well, the biggest power of 5 is to the power of 1. The biggest power of 7 is to the power of 1. And so all we now do is you write down, well, what are the factors involved? It's 5. What are the other factors involved at 7? What's the highest power we see? And the lowest common multiple is 35. Now, that may seem a bit like, oh my gosh, that's a lot of work for such a simple thing. But let me show you with another example now, before I let you loose on this, how useful this can become. My number has locked again. Let's see if I can change. All right. So let's say I have this question, 25 and 24. And I say to you, what is the lowest common multiple of 25 and 24? I think that is a little bit harder than the earlier one. So what I want you to do in preparation is I want you to find the prime factorization of 25 and 24. So will you do that for me now? So I want you to do it on your piece of paper. I'm going to stop and give you a minute to do this. what is the prime factorization of 25 and 24? And then I'm going to show you how we can find the lowest common multiple of 25 and 24, which if I had to do it the slow way, I would literally have to write out 25, 50, 75, 100, and we'd be here all day long. And then I'd start with 24, 48, 72. And oh my goodness, guys, we would be a long time. But because I'm a math teacher and I know about prime numbers and factors and all these good things, I will show you a way that lowest common multiples will never make you unhappy again. I promise. So what is the first prime factor that goes in 25? Ryan, I would, yes, please use the ladder, Ryan. That would be fantastic. So I've done 25 for you, and it turns out 25's prime factorization is just 5 times 5. Now, can you figure out the prime factorization of 24? Maybe write in the chat like, so for example, the first one, we can write it as 25 is 5 times 5. Write in the chat what you get for 24. I would love to see what you guys get for that. And then I'll show you, because remember, we're learning something slightly different now. We're not looking for the highest common factor. I'm going to show you this new method that helps us find the lowest common multiple. So someone said 4 times 6, I think it was Uko. Now the thing, Uko, is we need these to be prime numbers. And it looks to me like 4 is a composite number and 6 is a composite. So how can we break these down? Can you break them further? What I would say is the ladder method. You start by dividing by 2, and then you get 12. Okay, you're on the right track. And then we divide by 2 again, and we get 6. And then we divide by 2 again, and we get 3. And then what do we divide that by? We get that. So 24 is going to be 2 times 2 times 2 times 3. So this is what we call the prime factorization. And some people might even write, instead of writing 5 times 5, they might write 5 to the power of 2, because that means the same thing. It's called exponential notation, and it just means repeat multiplying twice, whatever's below. But I'm not going to stress too much about this. Okay, guys, here is the magic. When you get this, lowest common multiples are a piece of cake. Now, what's different about the lowest common multiple is when you are going to work out what it is now, you need to look at your ladder method and go, you're not looking for friends anymore. Lowest common multiples are not friendly. They like to be loners. You know, like L for loner, they like to just, hang out by themselves. All right. Now, if you look at across these two numbers, how many different factors are there? How many different prime factors are there? And I think there is a factor of 5, there is a factor of 2, and a factor of 3. Okay, now have a moment and look and see if you agree with me. There's no friends here. You don't have to look across. They're loners. So to me, the factors that are involved here are 5, 2, and 3. Okay, but that's not all we do. That's not the end of the story, but it's a good place to start. Okay. And so what we then do is we say, look, we're multiplying these factors together. But in addition to this, we have to look for the highest power, or basically when 5 occurs, how does it occur? It doesn't occur as a power of 1. It occurs like twice, or basically what is the power of 5 that it occurs as? And so we're going to write this as a power of 2, because there are 2 multiplications of 5 here. When we look at this number over here, we're not going to leave it as just a 2. How many times does 2 occur here? I think it occurs 3 times. And how many times does 3 occur? It only occurs once. Now, this is where it gets sneaky, guys. If you look at this, this is, and I know it's a bit tricky, but this is your lowest common multiple. You say, what are the factors involved? And when they do occur, how many times do they occur? So we get, and we might need our calculator, we're going to get 5 times 5, which is 25, times 8 times 3, which to me looks like it's going to be 600. Okay, so I just want to, I'm going to give you a chance to practice this now, but what I want to do is just highlight the method one more time. So step 1, I'll draw a ladder, right? Do the ladder method. Step 2, look for the factors, the loner factors. Or think of the loners. Think of the factors that are involved. I'm trying to think, maybe I'll draw it as the loner factors as an L. And then the last step is look for how often they occur. I'll maybe make a nice, but those are the 3 steps. Now I want you to try and practice this idea. I want you to try and do it with B and C. So I just want you to, for both of these, do the ladder method and then try and work out what the lowest common multiple is. And if you get stuck, you can always look back at this example. But I think this is a good time to just let you try and do this by yourself. We're going to open up the lesson for, if people want to ask comments, I will be available now. But the rest of us, we are going to put all of our attention into this part here. Okay, and Anya, anything that I need to know about from the chat stream?
No, so do you mind just zooming in a little bit for us as the numbers on the left are quite small? There we go.
So basically what we're doing is we're trying to find the lowest common multiple of 15 and 14. Now, if we did it the slow way, we would have to write them out and keep guessing. But instead, what I've said is you can start by doing the ladder method to find the prime factors of these 2 numbers. That's going to be your first step. And then you're going to try and remember what I showed you before. And even if you get stuck, not a problem. I'm going to go through this, a couple of times. And after this question, we'll have a little break too, because I know I've been pushing you. For those who are just on fire at the moment, you can do these, and it's pretty easy to see kind of how it works. But for now, the main focus is on B and C. Are there no questions, Anya, from students?
No, but can we use this as an opportunity to ask students if they may have any questions or so?
Yeah, if you'd like to ask an audible question, please put your hand up and we would gladly receive that. But if you want to put it in the chat, that's fine. Anya will watch that too. We're happy to help. So I'm thinking, okay, 2 doesn't divide into 15, but 3 does. So my prime factorization for this is going to be like that. And for 14, my prime factorization is going to be like that. So when you're finding the lowest common multiple, you first have to ask yourself, what are the factors that are involved here? And there are quite a lot of them. There's a 2, which is over here. What other factors are involved? Well, there's a 3. And then there is a 5. And there is 7. Now, if we look at these factors, is a 3 ever occurring as a power of 2? Or is there ever a 3 times a 3? No. The 3 is just occurring once, so it's a power of 1 here. The 2 also just occurs, there's no other 2s here, so it's a power of 1. Same here, same here. And so this is a little bit easier. The lowest common multiple is going to be 2 times 3 times 5 times 7. What's that going to be? What's 2 times 3 times 5 times 7?
So,
yeah.
Can I budge in here?
Yeah,
I
please.
just got 2 or so questions about students being a bit unsure about what the exponent or the power means. Another way you guys can view it is if you look there where Sir did the ladder method for 15. On the left-hand side, he's got 1 3 and he's got a 1 5.
Yes.
So if it was like 3 3 5, it would have been 2 3s and 1 5. So that's where the exponents come in. Murdy, please keep your microphone on mute. If you have a question, just raise your hand.
Yeah.
So for instance, at the number Sir is doing now, that exponent would be 3 to the power of 2. So that's how exponents work, if that makes sense. So that actually, it's like a counter for how many of those numbers there are. All right, thank you, Sir.
Cool. Yeah. So this will come out in the next questions when we do this. So just to show you here, the LCM, 2 times 3 is 6. 6 times 5 is 30. 30 times 7 is 210. Now, if you count in multiples up to high enough, you will see that the LCM of 15 and 14 is 210. So again, this is a little bit more tricky. And I want to give you the chance to try and do 20 and 30 by yourself, and then I'll give you some feedback. So I'm going to pause for a second, but if you'd like more explanations, so I think the best way to do it is just to try and see, can you do C? And then I will give you some feedback in a moment. And I can see that the part that I need to make clearer, though, is this powers thing, which I'm going to focus on soon. How do we know what the power is? And once you've got the answer to C, if you've got it, don't you want to put it in the chat? Okay. So I've done what I call my prime factorization. I'm not writing it out sideways or horizontally as well, because basically what this ladder says is it says 20 can be written as 2 times 2 times 5, and 30 can be written as 2 times 3 times 5. Now, in order to find the LCM, the lowest common multiple, some of you might have just seen this out of your head. I know the final answer has to be 60, because even if I count it in my head, 20, 40, 60, I get 60, or 30 and 60. So I know what the answer is meant to be, but I wanted to see if this method will give me that correct answer. So what are the factors involved here? The factors involved here are 2 times 3 times 5. Okay, now that is not finished yet. That is just the fact that I noticed there are 2s and 3s and 5s involved in this question. But how do I know what power is going to go here? So this is where I look around and I go, okay, there's 2s on this side and there's 2s on this side. I need to go for the biggest one. So if you look here, there are 2 lots of 2 here and there's 1 lot of 2 here. I always go for the biggest one. We can think of the loner factor being a bit greedy. And so this number over here has to be a 2 because of these two twos over here?
So,
Yes, go, Anya. Yeah.
while we're on that note, can you maybe explain to the learners why you chose, for instance, 2 to the power of 2 and not 2 to the power of 3?
Okay, good question. All right. So when we do this method, we always look for the biggest one. So if we're comparing it, we're always looking for the one that is the biggest, and we use that one. So we don't have to add these together. We never add them. We just say which of these two is bigger. This one is bigger. And so now we take whatever powers of 2 are with the bigger one. So that's the way I would remember it. So if we look, at this question, we're only looking at the powers of 2 on the one that has more powers of 2. It's a little bit of a weird, I know it's a bit of a weird method, but it really is effective and efficient. And I would go into why it works, but this format right now, there's not enough time. So for now, I'm focusing on just understanding the process. I'll do another example with you after this because I think you need that practice. But just to show you how it works for 3, why is there a power of 1 for 3? Well, there isn't a 3 on this side, so I ignore that side. There's 1 3 on this side, which is over here. And so what I do is I then just put a 1 over here. So I hope that helps in just clarifying. And then the same thing with 5. There might be a 5 on both sides here, but I'm just interested in, well, there's a 5 on both sides, but there's only 1 on each side. And so because none of them are bigger, they're the same size, we just choose one of them and it's a 1.
Perfect.
I feel like I feel like I need to do another example of that one just to, let me squeeze one more example in. So guys, I do realize, should I do 8 and 12? Let's do 8 and 12. So, and then we're going to take a break, I promise. If I say to you, what is the lowest common multiple of 8 and 12? I could actually do this the long way, the long way, and I get the answer pretty quickly. I would imagine that it's probably about 72, but we'll see now. If we follow this process, we take 8 and we divide by 2, we get 4, divide by 2, we get that, and we get that. So 8 is just 2 times 2 times 2. If we take the number 12, I also divide by 2, and I get 6. Then I divide by 2 again, and I get 3. And then I divide by 3, and I get 1. Now, what is the highest common factor for this 8 and 12? And how do I use this method? And this will bring it out nicely. If I look at these two things, there are only factors of 2 on this side. There's factors of 2 and 3 on this side. So how many unique factors are there? Well, I think there are only 2 2s and 3s. But now I need to ask myself, of these two sides, when I look at 2, what power do I need? Well, I'm going to only look at this side because this is the greedy one. This has the most powers of 2. So I'm ignoring for 2, I'm ignoring that side. And there are 3 powers of, well, there are 3 2s here. And so I'm going to put a power of 3. Now, when I look at for factors of 3, there's no 3s on this side. So I'm ignoring that. I'm only looking here. And there's only 1 3 here. So I give it power of 1. So now, if I look at this, this is my LCM. What is 2 to the power of 3 times 3 to the 1? It's just going to be, it's the same as writing 2 times 2 times 2 times 3, which is 8 times 3, which is 24. And do I agree that the lowest common multiple of 8 and 12 is 24? Well, let's count it. 8, 16, 24. And then 12 and 12 is 24. So actually, when I was guessing earlier, I guessed 72. But actually, the real answer is 24. I hope that's made it a little bit easier, guys. Just give me a thumbs up if that helped a bit. Give me a thumbs down if you feel very confused. I just want to get a feel for that. And I would love, I know I said I'd give you a break, but I would love for you to try and find me the lowest common multiple of 10 and 18. And if we get that right, then I feel like we can move on, or we can have a break, because I think we need a break.
So while we're on that, I just want to give like a big thumbs up from my side. I know that, for instance, Ria was mentioning to me that they're struggling a bit, but it makes me so happy to see they've got both thumbs up now after your explanation. So thank you, guys. Well done. And then while we do that, remember, we must just give the kids an opportunity to ask questions as well, eh?
Yeah. So I tell you what, while everyone is working on the lowest common multiple for 10 and 18, if you would like to ask a question, I'd love to hear a student's voice now. Please pop on and let us know how it's going. Give us a sense of or what you're struggling with. Pumuzile, please pop on the line. We'd love to hear your question.
Yes, sir. I was asking that the LCM, is it necessary to put it as an exponent, or to just keep it as a long way?
Yeah, no, you don't have to leave it as an exponent. It just is, it can use less space. And so sometimes as a teacher, I'll try and do that. But you can write it either way. Both are acceptable. Any other questions? I'd love to answer some questions while I'm doing the factorization here. Cool. Let me zoom in a little bit.
So we've got a question from Murdy.
Go ahead, Murdy.
Sir, I wanted to answer for age.
Ah, okay. Murdy, go ahead. I'd love to hear. Where do I go?
Okay, sir. My answer for age is 90.
Okay. I haven't worked it out yet, so let me try. The first thing I'm going to look at is what are my factors involved. So I know I have a 2, I have a 3, and I have a 5. If I look at both the 2s, the largest amount of 2s that I have on any one side is just 1, 2. And so that's going to be a power of 1. For 3s, the one side over here actually has 3 times 3. And so that gets a power of 2. And then for 5, it's only relevant on one side and it occurs once. And so I get a power of 1. So let's see if I agree with you. So 2 times 9 times 5, I get 90 as well. Guys, big up, big up. That was no joke, like figuring that out. So you would get, unless I've made a silly mistake, 2 times 9, 9 times 5, yeah, no, completely correct. So I think I've taken quite a bit of time to do the LCM like that. I hope that the ladder method is becoming easier and the LCM is getting easier. I want you to just take a moment to stand up because we're going to take a little break and we're almost done with the lesson. So we're going to go for just a little bit more, but just take a moment to stand up and give yourself a pat on the back because this has been quite a detailed exploration of this. And in fact, have you given yourself a pat? Give yourself a pat on the back for going through this. So what we're going to do now is, I actually think we're going to go, we've actually kind of used, I think we've used the time in an effective manner to help most of you, but we're going to do that fun little quiz that we spoke about at the beginning of the lesson. And so what we're going to do is I'm going to keep the room open for questions for the next 5 minutes for anybody who wants to ask questions. But for those of you who are ready to roll, Ms. Anya is going to put the link in the chat. And once you leave to go and take the quiz will probably take you about 10 minutes. And then you are class dismissed. So you can be done for the day. Okay, so what I'm going to ask is, Anya, if you could put the quiz link in the chat. And then for students who want to ask questions, I would love to hear your questions now, and I will answer your questions. So I saw some hands. Who is the first person that I'm going to be answering a question for?
It should be Ryan, Tando.
Go ahead, Ryan. Please go ahead. I'd love to hear your question.
So, when we are doing the LCM equals 2 times 3 times 5, do we have to put the power of 1, power of 2, power of 1?
So it depends on the question. So, for example, let me make up another example. So if we have 15, well, let's actually make something interesting. Let's go with, what is the LCM of 24 and 28, let's say. It's not easy to know what the LCM of 24 and 28 is straight away. You know, that it would take a long time. And we're looking for a number that basically both of these go into. And so what I do is I do this prime factorization, which I've been focusing on. And what you see is the prime factorization of 24 has lots of 2's in it. If we look at 28, it also has quite a few 2's in it, but it doesn't have as many 2's in it as 24. And so what I'm going to do is I'm only going to focus on the 2's in 24. That's essentially what it boils down to. So in this step, where I calculate the LCM, I first look and go, what are the unique factors involved in both of these? And the factors I see are 2, 3, and 7. Now, if I stopped here, I would be wrong because I haven't included everything I need yet, but at least I've done step 2. So now what I'm going to do is I'm going to say, well, which of these two numbers has the most 2's and how many 2's do they have? And to me, this one has the most 2's. And so I say, how many are there? There are 3. And so I put a power of 3 there. If I look for the factor 3, which of these two has a factor of 3? Well, it's this one over here. How many 3's do I have? I just have 1. And now I'm going to look at for 7's. Only this one over here has 7's. How many 7's does it have? It just has 1. And so what I'm going to get as my LCM is going to be 2 to the power of 3, or if I wrote it out the long way, like this. And so what do I get? I get 8 times, I mean, I might need my calculator for this, but essentially, this is the same as 8 times 3, which is 24 times 7. And then it's 140, I think it's 168, but I'll need to check that. And so you can practice more of these by watching the video again, but it's such a quick and clever way for finding the lowest common multiple. Okay, Anya, I'm about to head off. If you, Miss Anya will take any questions about doing the quiz. I know today's lesson was a little bit tricky, but I think if you keep practicing, we will get there. And, we're starting to now get some proper gym workouts in here. Like, we're really stretching your brain. And you may need to go over this a couple of times. Okay. All right, Anya, anything from you?
I just see Tando and Teddy still have their hands up, but sir, you can hop
No, it's fine. I'll take one more question. It's fine.
Okay. Tando.
Hello, sir.
Hello.
My question is, so as you said that with the LCM,
yeah,
and you find all of the factors. So do you write it as 2 times 2 times 2 times 2, or do you write it as 2 to the power of 3?
Okay, lovely question. This is really important. 2 to the power of 3 is exactly the same as saying multiply 2 3 times. So this is called power notation, and it's absolutely the same thing. So if you would like to, you could have, instead of writing this line up here, you could just say which of the two numbers has the most twos? It's this one. How many twos do I have? And I write it out 3 times. Then the next factor is 3. How many times does that occur? It occurs once, so I multiply it once. And then I look for 7s. How many times does it occur? It occurs once. So you're absolutely fine. You'll get exactly the same answer.
Okay. Thank you, sir.
Pleasure. There was one more question?
Sorry, I was on mute. It's Teddy, Teddy and then Murdy, but I see it's now 10-2, sir.
Okay. I'll take one more, then I'll go.
Okay, Teddy, still answer your question, and I'll still stay on 5 minutes for you guys. All right, Ted?
So, sir, if we're done with the quiz, we dismiss. We don't have to do anything else.
No, you're done. You're done for the week. Well done on completing the first course. And you go and have a good rest of your evening.
You too, sir. Bye.
Ciao, everyone. Okay, I'm out. Teacher out. I'll